Okay, welcome back. So in this video we are going to find the partial fraction decomposition of a particular rational function. We're going to be doing 5D on the Chapter 5 review. And this one is kind of hard. So that's why I chose to do it. So hopefully this will be helpful for you. The other ones are a lot easier than this. This is the hardest one. Okay. So, we've got our rational function here. And the first step we need to do when we're doing a partial fraction decomposition is we need to factor this bottom part, right? We need to be able to split it up so that we can actually split the whole fraction up, right? So we're going to factor that. And that's kind of the first difficulty with this problem, is how do we factor that polynomial? It's a degree 4 polynomial, so you could try like rational roots theorem, but if you'll kind of notice here, this is one where you have an x to the fourth and an x squared, and there's no x cubes or just x's by themselves. So you can do a substitution here to figure out what x is. And the substitution, to figure out what the factorization is. And to do that, you would set y is equal to x squared, because x to the fourth is x squared squared, right? It's x to the fourth is x squared, but then you've got to square it, right? You multiply the powers to get 4. And so you can rewrite this using this substitution as, if this is x squared squared, well, y is equal to x squared, this part, so it's going to be the same as y squared plus 5y plus 6. Okay? So by doing a substitution, we changed it into a quadratic polynomial, which is easier to factor. So now we're just looking at what numbers multiply to 6 and add to 5. Okay? Well, what would do that? We've got 2 and 3. Okay? So that guy is going to factor as y plus 2 and y plus 3. That's how it will factor. And so, but we didn't want y's in our answer, we wanted x's, so we'll put back in our x squared, which is what y was, right? And I'll just write the whole fraction again. So we've got 4x cubed minus 4x squared plus 11x minus 7. This would all be divided by, when we plug back in the x squareds, we get x squared plus 2 and x squared plus 3. Okay, so that's how that bottom can factor. Now we should check, can this factor anymore? Can the x squared plus 2 factor anymore? We would need numbers that multiply to 2 and add to 0. And there's no such numbers. Multiply to 3 and add to 0. That won't work either, right? The actual roots of these are going to be imaginary roots, and so they don't factor in the real numbers, at least. Okay, they do in complex, but everything factors in complex, so we don't really care about that too much. Okay, so this is as factored as it can be on bottom. Okay, so what does my partial fraction decomposition look like for this rational function? Well, I look at the factors on the bottom. So x squared plus 2 is the first factor. That's a quadratic and it doesn't factor, so we have to put a linear thing on top of it. Okay, and then we've got to add on Our second factor is x squared plus 3. It's quadratic and it doesn't factor, so we'd have cx plus d over x squared plus 3. Okay? Sorry, running out of space there. So now what we're going to do is we want to solve for a, b, c, and d so that we can get what the actual form looks like. Okay? So what we're going to do is multiply by the bottom to get rid of all the stupid fractions. So we're going to multiply by x squared plus 2 times x squared plus 3, and that will cancel out the bottom on that side. So we will get 4x cubed minus 4x squared plus 11x minus 7 is equal to. And then when we times it on this other side, the x squared plus 2 will cancel out on that first part, but we're left with x squared plus 3. So we get ax plus b. You know what? I'm going to just go to the next line already. We get ax plus b times x squared plus 3. Right? The x squared plus 2 is canceled out there. And then plus cx plus d, and then times, well, the x squared plus 3's would cancel out on that one, so the other thing we're left with there is an x squared plus 2. Okay? And now this is where we want to start solving for a, b, c, and d. Now the book usually does it a little bit differently for me, and I think the answer key does too. But what I like to do is I just plug in numbers for x and then try and find other stuff. Okay. Now for this one, it's a little bit difficult to do that because these don't have any roots. X squared plus 2 doesn't have real roots, and neither does x squared plus 3. So I'm going to have to be a little creative here. But if I do plug in 0, that will at least get rid of a and c. So I'm going to plug in x equals 0 to this equation that we had here. When we do that, we get 0 minus 0 minus 0, so negative 7 is equal to 0 times a is just 0 plus b times 0 plus 3, so 3, plus 0 plus d times 0 plus 2, so 2. So we get that negative 7 is 3b plus 2d. Okay? It's not too bad. Now the issue that we're going to run into is finding another value that we can plug in that will make this be nice. There's not really anything we can do. We're just going to have to start plugging in numbers. Let's see here. What can we do? I guess we'll just do 1. We are going to need 4 equations to be able to do this. So, yeah, so we'll plug in x equals 1. So we get 4 minus 4 is 0, 11 minus 7 is 4. Okay, 1, so a plus b. And then 1 squared plus 3 is 4. Plus c plus d. And then times 3. Okay. Okay. So now that we have that, well, there's 4 variables in that equation, right? So I'm going to do one more at least for a little bit, and then I think we might be able to get started on finding some stuff. So plug in, I'm going to plug in x as -1 in here. Okay. So when I plug in -1, I get -4 minus 4 is -8, minus 11 is -19, minus 7, so -26 is equal to -a plus b times 4 again, and then plus c plus d, or -c plus d, and then times 3 again. Okay. So what I'm kind of noticing here is that these two equations are pretty similar to each other. In fact, these line up, the 4's are the same, the 3's are the same. So what I'm going to do is I'm going to add those two equations together, because when I do that, I'm going to get a -4a, a positive 4a, a 3c, -3c. When I'm done, I will just have b's and d's. The c's and a's will cancel out. So we'll go ahead and try. Okay, so I'm going to add those two together. Let's see. So when we do that, the -26 becomes -22 is equal to, the a's cancel out, and so we get 4b plus 4b is 8b, and then the c's cancel out, right? 3c, -3c, those cancel out. 3d and 3d is 6d. Okay? So this is a really good situation to be in. So I added the two equations. So I added those two equations to get this. So now I had this equation from earlier that only had b and d in it, and then I have this equation that only has b and d in it, so I can solve for b and d now. Okay? I'm gonna give us some more space. So much fun, right? We'll probably need that one in a bit, but okay, so those are my two equations. -7 is equal to 3b plus 2d, and then -22 is 8b plus 6d. So I'll probably use elimination here. These two go into each other well, so I'm going to times this top one by -3. Times by -3 through the top, and we get 21 is equal to -9, and then negative 9b minus 6d, and then we've got negative 22 is equal to 8b plus 6d, and so then we can add these together. We get negative 1 is equal to negative b. Those cancel out, so then b is 1. Yay! We got b. Okay? So then what's d? D we can find by plugging in this b equals 1 and then solving for d. So, I don't know, we'll maybe do the top one. So we get negative 7 is b times 1 is 3 plus 2d, subtract over the 3, so we get negative 10 is 2d, so then d is negative 5. Okay? So that's half the battle. We got b and d. Okay? So I'm gonna, since we're basically done, well, we're at least done with b and d now. I'm just gonna make note of these on a different one so that we can come back to them. D is negative 5, and I'm gonna take this away. Okay. Okay. This is almost using all my whiteboards. Be interesting. Yeah. Wow. Okay. Okay, so we figured out on the last thing that b was 1 and d was negative 5. So now what I'm going to do with that is probably plug, well, yeah, we might have to get another equation, but I'm going to plug those into this equation here that I have. So we've got 4 equals a plus b was 1 times 4 plus c, and then we knew d was minus 5 times 3. Okay, so now I just need to find a and c, right? And so essentially I was plugging those in, so I had just an equation with a and c in it. So let's simplify this a little bit. We get 4 equals 4a plus 4, and then 3c minus 15. So, okay, so 4 minus 15 is negative 11, and then I'll just add the 11 over, so we get 15 is equal to 4a plus 3c. I just got all the numbers over there, so I kind of subtracted 4, added 15, and we get 15 there. So 4a plus 3c is 15. So that's one equation with a and c in it. The only problem is if I use the same equation with a and c in it, it should give us basically the same thing as what we had before. We combined these two up and got something with only b's and d's in it. And so those would be, these are very similar equations. So we might need to plug in one more value in for x. So let's just ignore this stuff. We've got all our information from that, and let's go back to our original equation, what we were dealing with here. was we knew our answer looked like this, and so we multiplied both sides by the x squared plus 2 to cancel things out, and so we got that this polynomial should be equal to this one. So let's just try plugging in one more thing. So set x equal to 2, we'll say, okay? So what do we get when we do that? 2 cubed is 8 times 4 is 32. 2 squared is 4 times 4 is 16. 2 times 11 is 22. Minus 7 is equal to A, so we've got 2A, and then B was 1, and then 2 squared is 4 plus 3 is 7, and then plus 2 times C plus D was negative 5, and then 2 squared is 4 plus 2 is 6. Okay, so I'm going to simplify this out a little bit. So 16 plus 22 is 38 is equal to 14a plus 7 plus 12c minus 30. Okay, and then we'll just simplify a little bit more. So when I subtract over the 7, I get a 31 over here, and then add over the 30, so we're going to get 61 is equal to 14a plus 12c. I believe, if I did not make a mistake somewhere. Okay. So, we are almost there, guys. Okay. So, we now have these two equations. This one and this one that have two variables. So, let's go ahead and I've used all my whiteboards. I'm going to copy down those equations on a fresh one, and we'll just do that. This is a terrible problem. I don't know if you've noticed that already. Probably have. 15 equals 4a plus 3c and then 41 or 61. 14a plus 12c. Okay. So how can we solve this? Oh, these two are pretty similar. So let's times this by -4. So I get 40, 20, so 60, -60 is -16a minus 12c. And then our other equation is 61 is equal to 14a plus 12c. We'll add those two together. The -60 and the 60 is 1, -2a, and then the c's cancel. That's not quite right. Okay, yeah, I realized I had made a mistake with my 61 equation. This wasn't quite right. I missed a -7 in my answer, and so this would actually be, we had done, I think it's 58 if I'm not mistaken. Yeah, it should have been 58. Sorry about that. I made a mistake there. Yeah, so 16 and then 20, so 38 minus 7 is 31, then, yeah, okay, so it's 58, so these should be, yeah, -2, so A is, divide by -2 is 1. Okay, and then C we can get just by solving, so we can plug in, wait, something is still off here. Oh my goodness. So, yeah, I made a mistake again. Anyway, this should have been 54. It was 61, right? And I had missed a -7 in my answer, so my answer should have been 7 less than what it was. So 61 minus 7 is 54. Okay, so this should be 54 here, which gives us this here. When we add those two together, will be -6. So A is 3. Okay, sorry about that. So A is 3, and then we just plug in to find what C is. So we plug it back in, we get 15 is equal to 4 times 3 plus 3 times C. So this is 12 plus 3C. And then we subtract over, so we get 3 is 3C, so C is 1. Okay, now I kind of don't think they'll give you one this hard on the test. It is a little bit easier if you do the other way, but essentially, like, once you have all these numbers, right, you just plug them back in to your original, what your answer should look like, right? And so we found out that B was 1 and D was -5 earlier. Okay. And so my final answer here was A is 3, so we've got 3x, B was 1, so plus 1 divided by x squared plus 2, and then plus B, or C, was 1, so x, and D was -5. Okay, so that would be our answer here. And that was extremely terrible, but the idea is you're just trying to find A, B, C, and D, and you have to do a bunch of algebraic crap to get that. I do think the method they show on the key is maybe a little bit easier on this problem, but I wanted to show you just how I would have done it, which definitely takes a while. Anyway, so hopefully that's helpful. I will see you guys later.